Hello everyone, this is the second video in the series of machine learning model made simple. So this video will discuss about logistic regression. So hope you all will enjoy it, and here comes the introduction part. So let's go. So logistic regression is a supervised learning model and ultimately a classification model, and it is used to predict binary outcomes for a given set of independent variable, and the dependent variable's outcome is distinct. As we are already familiar with the definition of logistic regression, let's move on to an example. So as you can see on the left side of the screen, we have a example of logistic regression. So it is that if we want to categorize apple from the rest of the fruits, we provide it with a data set which already contains labeled data that it is an apple. So system predicts future outcome based on training from a past input, like whether it's an apple or not, so it will categorize it into that. So it's an example of binary classification also. As for those who have already seen my previous video on this series, on which we did prediction on insurance amount using linear regression, so the logistic regression works on the classification. So we change the problem domain, we determine whether the person will get the insurance or not, and it is the perfect problem domain for logistic regression. So here is the graph showing the dependent variable age of who got insurance versus probability of getting it. So this graph plot an indication of probability of something to occur or not. Looking at the graph, we can see the probability is plotted along with a value space, example time, with a threshold value. It makes a S-shaped curve. So if probability is less than 0.50, it will occur. If it's less than 0.5, and if it's 0.5, then it's most likely to occur, and if it's less than 0.5, then it will not occur. The coding part, as you can see that we first import the sklearn library, and from that we import the dataset load iris, and then from linear model we import the logistic regression model. So we first split the training and testing data using load iris function, and then we put it in the logistic regression function and fit it with that data set. So then we predict whether test image is a array which category. So first and we get that 0 array as a result, and then we predict the probability, and we get this probability array for that same data sample, and then we check the score of the training versus test data set, and it gives an accuracy of 0.97. so it's a pretty good model. So yeah.